We're going to continue working with some extra percentage practice here. Looking at part A, it says, suppose that we have 500 Moraine Valley students. We're asked whether they liked math or not. If 34% of students like math, how many students in the sample actually said that they like math? So we're going to focus on some calculations with percentages here. And you'll notice up above I have a formula that I'm going to be using throughout these problems in this video, where I have the percentage in its decimal form is equal to just the part divided by the whole. I, in general, prefer to work with the percentage in its decimal form because I don't have to multiply by 100 every single time. You can often do that pretty easily mentally once you've gotten a little bit more confident with your percentage work by just sliding that decimal to the left or to the right. So I'm almost always, if I'm given a percentage like I am right here, I'm almost always going to immediately convert that to its decimal form first and say, okay, 34%. There's two different ways I can convert that. I can take 34 and I can divide it by 100. And if you grab your calculator and work that out, we should end up with 0.34. Or you could say, well, 34%, I'm going to take the decimal and I'm just going to slide it to the left by 2 spots to get 0.34. So it's kind of just a matter of preference. I think in general it's going to be much faster to just be sliding that decimal to the left or to the right as you get a little bit more practice. But if you feel more comfortable dividing or multiplying by 100 for now, by all means, feel free to use that. So there's a couple different ways that we can think about it. I like this formula right here when we're first getting started, especially if you're not feeling super confident with your percentage calculations. So I would take, first of all, the percentage in its decimal form, which is just 0.34. So 0.34 is equal to, I just have to figure out what's the part and what's the whole. In this case, the whole is the total number of students that I surveyed, which in this case would be the 500 Moraine Valley students that I have right there. So of the 500 Moraine Valley students, that would be my whole. How many of them liked math? That's the part. I want to know the part of my overall 500 students that actually said that they liked math. So we can give that a variable name. I just gave it the name X, but you can use whatever letter you want. And in this case, we just have this small, tiny equation that we can solve by multiplying both sides by 500. So if I multiply both sides by 500, I end up with X is equal to 500 times 0.34, or X is equal to 170 students. Now, as you get more and more comfortable with your percentage work, you may not need this formula that we have up here. But for now, if it feels like that gives you a little bit of structure and it kind of just makes you feel more comfortable with these problems, by all means, continue to do that. But in general, most of the time, I'm just going to jump straight to, well, I'm taking the total times the percentage in its decimal form, and that'll give me that percentage of my total number. Moving on then to part B. Part B says in one class, 37.5% of students like math. We also know that 12 students like math in this class. I want to know what is the total number of students in this class. So this is kind of a circumstance we don't often see when we're working with percentages. Usually we're trying to find the percentage of a total. Here I'm actually looking for the total. So in this case, I might actually use the formula that we had up there. So 37.5%. Let's give that real quick. 37.5%. I know I can convert that to its decimal form by moving the decimal to the left by 2 spots. So that would be 0.375. So the percentage in its decimal form is 0.375 is equal to the part. So this is the number of students in my class that like math, which that would be 12. I want to know the total number of students. That's what I'm trying to solve for. So in this case, I'm trying to solve for X. So in this case, I actually have a little bit more work to do. I'm going to have to do 2 steps instead of 1. I need to, first of all, get X out of that denominator. I can't solve for X while it lives in my denominator. So I'll multiply both sides by X, multiply both sides by X. On the right-hand side, these two should cancel out. So 12 is equal to 0.375 times x. And then if I want to solve for x, I'm going to divide both sides by 0.375. Divide by 0.375. So that means that x is equal to 12 divided by 0.375 gives me 32 students in total in this class. So this is a case where I actually probably would use the equation because it's not often that we're trying to solve for the total. Usually the total is the number that we have. Last question down here, part C, it says a hospital employs 400 nurses and 30% of them are male. How many male nurses are there? So again, if I wanted to use that shortcut here, I'll show it both ways. Using the shortcut, first of all, 30%. To convert that to its decimal form, we can just move the decimal to the left 2 times, so that would be 0.3. If you want to say 0.30, that's fine. That second zero doesn't really matter. It's just going to be 0.3. So if I wanted to use the formula, I would take the percentage in its decimal form, 0.3 is equal to x, the number of male nurses, I don't know what that is, divided by the total number of nurses, which is 400, and I can solve for x. So I multiply both sides by 400 times 400, and I end up with 400 times 0.3, or 120 male nurses as my x values. Male nurses is my x. Or again, if you start to feel more confident with these, you could just say, well, I'm going to take the total number, 400, times the percentage in its decimal form, 0.3, and I should end up with exactly the same thing as 120. You can see that that's what we're doing right here, but if you don't feel like you need to set up that equation, then by all means, you can use that shortcut as well.